Welcome everyone to physics seminar for MSc first year's physics students. Subject physics of semiconductor devices, and the seminar topic is junction breakdown and its method. So let's start with what is junction breakdown. So, junction breakdown is when sufficiently high field is applied to the PN junction, the junction breakdowns and conduct a large current. Now, the there are four type of junction breakdown. The following four breakdowns are thermal instability breakdown, secondly, tunneling effect breakdown, third, avalanche multiplication, and fourth, Zener multiplication or Zener breakdown. So let's get started with all the type of breakdowns one by one. First, thermal instability breakdown. Breakdown due to thermal instability is responsible for the maximum dielectric strength in the most of the insulator at room temperature and is also a major effect in semiconductors with relatively small band gap, example germanium. Because of heat dissipation caused by reverse current at high reverse voltage, the junction temperature increases. The increase in temperature in turn increases the reverse current in comparison with the value of lower voltage. The temperature effect on reverse IV characteristic is shown in figure on the given screen. Each line in this figure represents the current at constant junction temperature. The heat dissipation curve is proportional to IV product, which is shown as straight line in the plot. These lines correspond to curve of constant junction temperature. The reverse current voltage characteristic of the junction is obtained by joining the intersection point of the curves. Now, because of heat dissipation at high reverse voltage characteristic shown a negative differential resistance. Now moving towards the second type of breakdown method, which is avalanche breakdown method. Now, let me first explain the basic concept behind the avalanche breakdown. The basic concept is it occurs when high reverse voltage or is applied across the diode. As we increase the current, the applied reverse voltage, the electric field across the junction also get increases. This electric field exert a force on the electron at junction and free from the covalent bond. These free electrons starts moving with high velocity across the junction and collide with each other, thus creating more free electrons. This rapid increase the net current. This is the basic concept behind the avalanche breakdown. Now the proper definition should be the process of applying high voltage and increasing the free electron or electric current in semiconductors and insulator material is called avalanche breakdown. Now let me tell you some of the characteristics of this breakdown. This is observed in Zener diode having Zener breakdown voltage Vz greater than 8 voltage, means this type of breakdown is seen in Zener diode which is having greater than 8 voltage Vz. Second, the increase in temperature increases the breakdown voltage. The Vi characteristic curve of avalanche breakdown is not a sharp curve. As the breakdown depends on doping densities, this breakdown is seen in lightly doped diodes, means those diodes which are lightly doped, those diodes only shows avalanche breakdown. Some mathematical equation behind this avalanche breakdown is the ionization rate is qualified by the ionization constant of electron beta and holes alpha. These ionization constants are defined as the change of carrier density with position divided by the carrier density. Alpha is equal to d nu by nu dx and beta is equal to dp by nu dx. The impact ionization mechanics is used to generate microwave power in impact devices. Also, it is used to amplify optical signals in avalanche photo detectors. So next type of breakdown is Zener breakdown, which is somewhat linked with the avalanche breakdown. So Zener breakdown is when the diode is reverse biased, the kinetic energy of electron increases and they move at high velocity. The high velocity electron collides with each other and give rise to more free electrons. Now these free electrons in turn give rise to high value of reverse saturation current. This is known as breakdown in simple language. Definition: the process in which the electrons move across the barrier from the valence band of p-type material to the conduction band of n-type material is known as Zener diode. Some of the characteristics of Zener breakdown is: this is observed in Zener diode having Zener breakdown voltage Vz of 5 to 8 volt. See, this Zener breakdown is also somewhat related to avalanche breakdown. We have seen or discussed in earlier part in avalanche breakdown. It was this type of avalanche breakdown was seen in 8 voltage breakdown, and Zener diode is seen in Zener breakdown voltage of 5 to 8 voltage. These both breakdowns are related to each other. The increase in temperature decreases the breakdown voltage. Next, the VI characteristic of Zener breakdown has a sharp curve, and that in avalanche breakdown it was not that much sharp curve. It was a different curve. Now this type Zener breakdown occurs in diode which is highly doped. This type of breakdown is seen in diode which is highly doped, as the breakdown depends on the doping density of a junction. Now, as applied voltage increases, the electric field increase. If electric field intensity reaches up to the maximum value, then the bonded electron in depletion layer excited to the conduction band and create electron hole pair. This electron hole pair, when moved through circuit, develops current. This breakdown is called Zener breakdown. Thank you.